All right, we are looking today at quadratic functions. Now, we have already done a good deal with quadratic functions, so some of this is going to be review, but that's okay, we'll take it. So please remember, we've talked about before that a polynomial function with a particular degree, like in this case a quadratic, is a degree of 2. And so again, they give us an example there of what a polynomial is, and then several specific suggestions like if you have a constant, it has a degree of 0. If you have a linear equation, it has a degree of 1, x to the first, right? And if it's a quadratic, it's a degree of 2, so x to the second. All right, what does a quadratic graph as? A parabola, yeah. So if your leading coefficient is positive, which way is it going to open up? It's going to open up. And if it's negative, which way is it going to open up? Down. So if it's opening down, it's changing from increasing to decreasing, right? And so that means that our highest point there is going to be a maximum. Now, that also has another name. It's called the vertex of the parabola. And the axis of symmetry runs right through that vertex, all right? If instead the parabola opens up, we will have a minimum there. And again, that'll be at the vertex, and the axis of symmetry will run through that vertex, all right? So two different forms that we might find the equation of a quadratic, all right? We have the one we've worked with a lot, ax squared plus bx plus c. That is actually not its standard form. Its standard form is y is equal to ax minus h squared plus k. And the reason that is its standard form is you can just look at it and see your vertex, because your vertex is going to be hk. Now, go back to the idea of shifting that we've already learned, okay? We know what x squared looks like. That's one of our toolkit functions, right? And so we said any value subtracted from x is a horizontal shift, and any value subtracted from y is a vertical shift, so that our shift would be a positive h, positive k. So that makes sense then that if we start at 0, 0, and we shift a positive h and a positive k, our new vertex would be hk. All right? So if we want to go from the ax squared plus bx plus c form over to the ax minus h squared plus k form, we're going to complete the square. All right? So we've done completing the square before, but let me show you it's a little bit different for this. So let me show you how you do that. So step number 1, we're going to move the constant to the other side. So let's take this positive 7 right here and subtract it over to the other side. So it's a negative 7. All right, then we're going to factor out a. Now, when we did this before, we divided by a. If we had like a leading coefficient, we divided it out. We're going to factor it out with this. And we'll see why in just a minute. All right, so if I take 2 out of 2x squared, I'd have x squared. Take 2 out of 8x, and I'd have 4x. So now I'm ready to complete the square, and we're going to do that the exact same way we did it before. We're going to take the coefficient of the middle term, cut it in half, and square it, and add that to both sides. All right, so coefficient of the middle term, what's your coefficient of your middle term? 4. If we cut that in half, 2, and square it, 4, and we're going to add that to both sides. Now, when I added this 4 right here, it was inside parentheses being multiplied by 2. What did I really add to that side? 8. So I have to add 8 to the other side. So look at that one more time. To complete the square, we took the coefficient of the middle term, 4. We cut it in half, 2. We squared it, 4. And we added that to both sides. But that 4 is inside parentheses being multiplied by 2. So what we really added to that side was not 4, it was 4 times 2. What we added was 8. So if we add 8 to one side, we have to add 8 to the other side. Okay, so now we can clean up what we've got. So we can say negative 7 plus 8 is going to give us a positive 1. And then this x squared plus 4x plus 4, what's that going to factor to be? 2 and 2. So we're going to have x plus 2 and x plus 2. So that would be x plus 2 squared. So that's how we can convert it from the ax squared plus bx plus c form to its standard form. All right. We also, you might prefer to write it this way where you can see the value that's being subtracted from y over here. We also can subtract that 1 over to the other side, and that would be the traditional standard form. And again, my goal is to be able to look at that and see my vertex in that form. Okay, so here's what I got from all that work. Which way does this open? How do I know? It opens up. How do I know? Leading coefficient is a positive 2, so I know it's going to open up. And then the most important thing that I would get from all of this is my vertex. So if you compare this equation we just created with the standard form equation up here, we're looking for the vertex, which is hk. So what's h? Negative 2. And what's k? Negative 1. Yes, so our vertex would be negative 2, negative 1. That is all I get from all that work. I would propose to you that there is a faster, easier way to get that same information. And here it is. Another way that we could find, all we got from that was 2 things, right? Which way it opened and what the vertex was. I can look at this and see which way it's going to open. Which way is it going to open? Up, because it's a positive 2, right? So really the only other thing I need is the vertex, right? Well, you might remember that the x value of your vertex is equal to negative b over 2a. And once you know what x is equal to, how do you find y? Plug it in, yeah. So let's try that, all right? So looking back at this, just like we did before with quadratic formula, we're going to identify a, b, and c the same way. So what's a? 2, what's b? 8, and what's c? 7, all right? So we're going to do negative b over 2a. So again, b is 8, so negative 8 over 2 times a, what was a? 2, yes. So we're going to get negative 8 over 4. So what is the x value of our vertex? Negative 2. All right, then once I know x is negative 2, you told me to find y. I would just plug that negative 2 back in. So let's do that. Let's take negative 2 and put it back in the place of x. So we had 2 times x squared, so that would be 2 times negative 2 squared. 8 times x, that'd be 8 times negative 2, and then plus 7. All right, so negative 2 squared is 4 times 2. All right, then we would have, okay, so we had negative 2 squared is positive 4, right? So 4 times 2 would be positive 8. All right, then here we're going to have minus 16, so 8 minus 16. Negative 8 plus 7. Negative 1, right? So you told me it opens up, and there's my vertex, negative 2, negative 1. I got the exact same information with this little bit of work right here that I got from all of this work up here. Okay, but Ms. Wetmore, what if it tells me, like it gives me the equation in ax squared plus bx plus c form, and it tells me that I have to write it in this standard form. Then I have to complete the square to do that, right? No. Because what do I need to create this equation? I need a. What's a? 2, and I need hk. So what's hk? Negative 2, negative 1. So all I have to do then is come over here and put negative 2 in for h and negative 1 in for k. And there is that exact same formula, no completing the square required. So I know completing the square is your favorite thing ever, and you will be devastated to not get to do it. So you can do completing the square here if you want to, but you do not have to in order to get this into standard form, right? So again, if I'm trying to write standard form, I need a. which it doesn't matter which of these two forms I was given, this one or whether I was given this one or this one, it wouldn't make any difference. I could see A. And then I can find HK just by doing negative B over 2A to get my X value of my vertex, and then plugging that in to get the Y value of the vertex. So again, we're going to put in the X value and the Y value, and there's our equation. Now, if they give it to me in this form, of course, I'm just going to look at that and say, okay, A is 2 and my vertex is negative 2, negative 1. Fabulous. But if they give it to me in the AX squared plus BX plus C form, then that's a way that I can get that other form as well. Okay, so whichever way we go, now we're ready to graph it. So let's go ahead and plot our vertex at negative 2, negative 1. And we've said that this is going to open up. What is that 2 out in front going to cause? Stretch, yeah. Vertical stretch by a factor of 2. So that's silly putty, right? That's when we're grabbing the silly putty top and bottom and stretching it twice as high. So what does it do to Charlie Brown's face when we do that? Yeah, it makes it taller and skinnier, right? So it's going to do the same thing to my graph. It's just going to make it a little taller and a little skinnier. So, you know, our normal parabola is a little fatter. This one's a little taller and skinnier. It's just a sketch. Now, if instead of giving a sketch, they wanted me to be a little more accurate and they wanted me to give a little more information, they might ask me to plot some points. What are usually the easiest points to plot? Zeros, yes. So X and Y-intercepts, yes? Okay, so how do we find X-intercepts again? Plug in 0 for Y. All right, so let's do that. Let's come down here and let's take our equation and let's put 0 in for Y. Okay, so how am I going to solve that? What's the easiest way to solve that? Calculator. Yeah, I could throw that into the quadratic in my calculator. If it would factor, I'd factor it. If it wouldn't factor, or if I didn't have my calculator, I could always do it by hand. Okay, so you don't need to write this down. But I was just reminding you, because we did quadratic formula already this year, I was just reminding you it would be negative b plus or minus the square root of b squared minus 4ac all over 2a. The song's going in your head right now, right? All right, so again, you don't need to write that down, but we could put it in our calculator program, and if we couldn't, if we didn't have our calculator, it wouldn't factor, then we could use the quadratic equation. Okay, so I get down here, and the solutions that I get are negative 1.3 and negative 2.7. So if you come back up here, negative 2.7, yeah, that looks promising. And then a little bit past negative 1. So that would give me the 2 points that I need to be more precise with my graph. All right. Also remember the way that we did this in our calculator. You've got to have that program that I linked to you. Okay. If you haven't linked it yet, you can link it from me at your convenience. I've also uploaded it to Canvas, but it's easier just to link it in person. So all that we would do is we would go to Program, and we would choose quadratic, and then you're just going to enter your A, B, and C values. So we had said A was 2, B was 8, and C was 7. And so remember that when it displays your answer, one of the answers scrolls off the screen. But what you're looking at is negative 4 minus the square root of 2. Remember, in front of the radical, there's always a plus or minus. So it would be negative 4 plus or minus the square root of 2 over 2. The plus is the one that scrolled off up there. Okay? All right. So now we have x-intercepts. A couple of other things that they might ask us to find. They might ask us to find domain, range, axis of symmetry, y-intercepts. So let's just go ahead and find all of those things. All right? So domain. All right, your domain is going to be all real numbers unless one of two things happens. What are they? 0 in the denominator. Yep. Square root of a negative, fourth root of a negative. Yeah. So a negative under an even index radical. So here's my equation right here. Do you have a fraction? Do you have a radical? Yeah. Well, when we did quadratic formula, we did. But like the equation itself? No. So what's your domain? All real numbers, right. You also could look at your graph if you want to. If you look at your graph, you can see this is just going to keep going this way. And then this side over here is going to keep going that way. All right, so either way, our domain is going to be all real numbers. Is your range going to be all real numbers? No. All right, so let's look at the range. So if we start down here and we start coming up, what's the first y value that we use? -1, and then we go to where? Infinity, right. So we could say y is greater than or equal to -1. Now, here's a little shortcut for that. If your parabola opens up, like ours just did, it's going to be from the vertex up, right? What if your parabola opened down? What would it be? From the vertex down, yeah. So a little bit of a shortcut for that is that if it's opening up, it's always going to be y is greater than or equal to the y value of your vertex. And if it's opening down, it's always going to be y is less than or equal to the y value of your vertex. So you can use common sense to figure that out. But if you're more of a formula person and you'd like a way to remember it with a formula, there you go. All right, remember that we said our axis of symmetry is what runs right through the center of the parabola, and that also means it runs through the vertex. All right, that axis of symmetry is the vertical line. What is the equation of every vertical line? X equals or y equals? X equals, right. So if it's x equals and it runs through the point -2, -1, what does x equal? -2, right. So our axis of symmetry would be x equals -2. So what would be kind of like a formula way to remember that? What is my axis of symmetry always going to be? X equals h. Perfect. It's always going to be x is equal to the x value of the vertex, which is h. So x is equal to h. Yes. Okay, let's talk about the y-intercept. How do we find the y-intercept?
Plug in 0.
Yes, plug in 0 for x. All right, so let's do that. Let's find our y-intercept by putting 0 in for x. Okay, so again, here's my equation. So if I put 0 in for x, what am I going to get? 7, because it's 0x squared plus 8 times 0 plus 7. So 0 plus 0 plus 7. So my y-intercept then is going to be 7, or you could write that as 0, 7. And if we come over here and look at our graph, that makes sense, because look, we've got 1, 2, 3, 4, 5, 6, 7. It makes sense that if we extended this on up, that'd be about where it would hit. So that looks good. All right, they also could ask us for intervals of increasing and decreasing. We just had that on our last test. All right, so let's start over here. What's my graph start off doing? Increasing or decreasing? Decreasing, right. So it's decreasing. It's going down, right? So it's decreasing from -infinity to where? -2, because we use the x values, right? Then what happens at -2? It starts increasing, and it increases to where? Infinity, yeah. So we could say increasing from -2 to infinity and decreasing from -infinity to -2. Remember, with intervals of increasing and decreasing, we always use the x values and we always use parentheses. Okay, so my graph switched from decreasing to increasing. How did we define that? As a relative maximum or a relative minimum? Minimum, sure. And remember that we also said up here that if your parabola opened up, you would have a minimum at your vertex. So yeah, that all goes together. All right, what is that minimum? -2, -1, What if they just asked me for one value? Would it be the x value or the y value? The y value, yes. All right, and on WebAssign, they do that. On WebAssign, instead of having you give the ordered pair, they'll say, what is your maximum or what is your minimum? And they want the y value, okay? Because that's how high it's going or how low it's going. So we want to be sure to give the y value, okay? All right, so let's look at a couple of applications of that, all right? So for the first one, they tell me we have a quadratic that has a vertex at 1, 2, and it goes through the point 3, negative 6. And they want us to create the equation in standard form. All right, so standard form, I need A, H, and K. What do I already know? H and K, because that was the vertex, right? So what am I going to put in for H right here? 1. And what am I going to put in for K right here? 2. So go ahead and plug those in. So 1 for H, 2 for K. So now all I need to do is find A. How could I find A? Yeah, plug in X and Y. If they gave me a point that this parabola goes through, if it's a point on the graph, doesn't it make the equation true? So I could put 3 in for X and negative 6 in for Y, and that only unknown then would be A. All right, so let's do that. Let's put 3 in for X and negative 6 in for Y, and the only unknown will be A. So go ahead and find A, if you would, please. All right, so 3 minus 1 is going to give us 2, and 2 squared is going to give us 4. So now we have 4a plus 2 is equal to negative 6. I'll subtract 2 from both sides, so 4a would be negative 8. And then I'll divide both sides by 4, and a would be negative 2. So let's bring it back up, and let's put it in the place of a in that equation. So that would be negative 2, x minus 1 squared plus 2. Negative 2, x minus 1 squared plus 2. So that would be our equation in standard form that has that vertex and goes through that point. Now, there are tons of real-world examples that follow a parabolic path. Okay, the first example they give us here, it says the path of a baseball is given by the function f of x. So you can see that function right here. What's that going to graph as? A parabola, opening up or opening down? Opening down, all right? So if you think about it, that makes sense, right? If we're standing here at home plate, we hit the ball, it goes up, it comes back down, it follows a parabolic path, so that makes sense. All right, it asked us, what is the maximum height reached by the baseball? All right, so let's think about, what is this x value down here going to represent? The distance, yeah, the distance away from home plate, right? So here's home plate and it's going out here out in the field somewhere. All right, then what's our y value going to represent? Height, yes, because that's how high the ball goes. So when they ask me what's the maximum height reached by the ball, what do they want? The maximum y value, yes. And where does the maximum of a parabola occur? The vertex, yes. So we need to find our vertex, yes? Now, we learned 2 ways today to find the vertex. One of them was completing the square. You want to complete the square on this mess right here? No, thank you. So let's do negative b over 2a. All right. So what's b? 1, and then a is that decimal, right? So we're going to do negative b over 2 times, and then a is going to be that decimal. All right, grab your calculator because we're going to want to play with the calculator in just a minute anyway. So go ahead and type that into your calculator and see what you get. All right, so are you getting 156.25? Everybody getting that? Anybody having trouble? I'll come look at it with you. All right, so once I know x, how do I find y? Plug it in, right. So I'm going to take 156.25 and I'm going to put it in the place of x in this equation. All right, so I'm going to put in 156.25 in the place of both of these x's in that equation. All right, throw that one in your calculator and see what you get. All right, did you get 81.125? Yes. All right, so what is the maximum height reached by the baseball? Is it the 156.25 or the 81.125? The 81.125, right. Remember that the maximum or the minimum is going to be your y value. Okay, so in your graphing calculator, let's put this in. And let's see if we can get our calculator to find this for us. So I'm going to jot down the equation real quick here. All right, so again, we want to go to y equals. And we want to put in that equation. I'm going to clear out the other stuff that I have in here from what we were working on the other day. If you still have a plot on from the other day, you'll be able to tell, because see how up here plot number 1 is darkened? If you just hit enter, that turns it off. Hit enter again, it goes dark again, it turns it back on. So that way it won't interfere with what we're doing. Okay, so our equation this time was a negative 0.0032x squared plus x plus 3. And again, remember whatever I touch lights up red so you can see the sequence that we're doing there. All right, and when I graph, I usually start with a zoom standard. That's the tens all the way around. So I'm going to go to zoom number 6, zoom standard. Oh, what is wrong with my stupid calculator? Like, this is supposed to be a parabola and it's telling me it's a line. What's wrong with it? Usually when I think there's something wrong with my stupid calculator, it's usually operator error. So what's wrong? Why am I seeing a line instead of a parabola? What? It's too zoomed in. I'm seeing tens all the way around, right? Think about your graph. Your graph went up to 80, right? And then it went out to like 300 something. So if I'm just seeing a tiny little corner of the graph, of course it's going to look like that. Well, you know, there's this button on the calculator that Miss Wetmore hasn't showed us that I know that's like the secret button. It's called Zoom Fit, and it'll just set the window for me so I don't ever have to worry about it or ever have to do it. Okay, let's try that. Here's why Miss Wetmore hasn't shown it to you. That's what your calculator said is the perfect window for this graph, right? So you are smarter than your calculator. Let's go to window and let's set this window for what we want to see, okay? So what y values do we need to see? Where did the baseball start? 0. And then how high did it go? 81. So maybe I'll go like 0 to 85 or something like that. Probably don't want to count by ones. Which one to count by? 10 sounds good. All right, then what about our x values? So we started at 0 distance away from home plate. And then when we were at the Vertex, how far were we? 156. So we still have to go another 156 to get back down again, right? Yeah, so sounds good, 320, I like that. All right, then what do you want to count by? 20 sounds good. So again, you can tell your calculator what you want to see. There's our parabola. See, you're smarter than your calculator. All right, so now, remember how I can get my calculator to tell me what the maximum is? Do you remember where that is? Yes, second trace is where our maximum and minimum button are that we've used before. All right, so this time we have a maximum, so I'm going to go select maximum. I think my maximum is about right here, so remember it's going to ask me for a left boundary right here, so I'm going to go a little bit to the left with my left arrow key and hit enter. And again, I think it's about right here, so I'm going to go a little bit to the right and hit enter. And then it wants a guess, so I'm going to go back about as close as I can get. And it tells me that my maximum is 156.25, 81.125. That's the same thing that we got algebraically, right? So, which was faster? Algebraically or on the calculator? So, how long did it take me to do negative b over 2a and get this, and then throw that in and get the 81.125, right? I think we did that in maybe a minute. And then how long did it take to redo the window and change all that stuff and use the maximum button and find all that on the calculator? So again, don't forget that when we tried to do the zoom standard, we couldn't see the parabola. We even tried that zoom fit and that didn't work. And so instead we went back and we manually set our window and we got our parabola, and then we used our maximum button to verify that answer that we had just gotten. So this one probably faster and easier to do by hand than to go through all that on the calculator, but it is nice to have two ways that we can do it so we feel confident about our answer. All right, questions.